this in the repo. Do some work while I'm waiting for this. What's the markdown thing to preserve the
I like that. That's a cool way to kind of sketch things
I'm
out.
not sure if that's gonna work. Yeah, to kind of summarize, I mean, this is the kind of stuff I would like to see for me to understand. So I'm just gonna show you guys what I feel would make me understand. So
Yeah, showing every core details of API is a lot of time and also easy to forget.
yeah, it's too much at one time. It's better to just get like a pretty good like overall catch-all, I think.
You need to initialize OpenXR before OpenGL for swap train.
Yeah, OpenXR goes first, and then OpenGL goes next.
Okay.
Because you have to have the instance, which represents the runtime, and everything kind of gets put into that. So that's got to be there first. I'll go into it in more detail.
This might be off topic and maybe ahead of myself, but while we're waiting to get started, does OpenXR have libraries for like Android NDK?
Yeah, so the SDK, the OpenXR SDK, it includes the Android platform. So there's code in there. If you look at the SDK, this is the code for the SDK source. If you look at the program, I think, or the main at the bottom or at the top, there's Android specific use Android platform declaration.
Interesting. Well, thanks.
Yeah. But if you're talking about like the Quest 2, though, I delve into that a little bit because I have one. That's what I'm going to demo with today, and they have their own SDK, which is based on OpenXR. So it's easier to set up. But I haven't tried this way. I've only done this way for PCVR with the source SDK. But this is the one that they have. If you look at Oculus Quest 2, OpenXR SDK, they have a page for that where you can download it, and that's where I got this from. This zip is download page. Yeah, this guy. So 42. Oh, I'm already behind. I just got this like 2 days ago. All right, so if you click on that, I guess I'll just download it again. Yeah. I just got this. Like, let's see, when was that? The 17th. Now they're on 42 already. So it's changing pretty fast. But I have it deploy. I have one of the examples deployed onto the Quest 2 if you want to see it at the very end. It's a bonus. It's an extra. If we had time, we'll get to that. Let's see. Does that answer your question?
Oh yeah, definitely. Thanks.
Yep.
I think we can start maybe.
Okay.
Cool.
Alrighty. Let's see how to do this. Sure. Okay. Welcome to the introduction for OpenXR. And so today I'm gonna give you kind of a overview of OpenXR, what it is, some code for it, some demos, the code, and how to use it in general. So the presentation format will be this. So we'll go with the intro first. Then I'll show you the video of the program running, so you can kind of have an idea of the end result. Although it's going to be only on the screen, you won't be able to see the full glory of it because I'm wearing the headset. Well, in the video you won't be able to, but in the demo you'll be able to see me moving my head. But then I'm going to go into the high-level components of OpenXR, and I'm going to go into the app structure of an OpenXR app. Then we'll look at the pseudocode, and this is a thing I just made to kind of demonstrate a high level what the project code entails, so that we can wrap our minds around it easier instead of going to details of each nitty-gritty part. And then we'll have the code components of each part of the broad part of OpenXR, the structures and the classes and the enums that go into the app. And then we'll have the project demo, which is like a reflection of what the video is. Then we'll go into looking at the code, 628 lines for the app. So it's shorter than the famous Vulkan 1,000 lines to a triangle app, but still it could get pretty big. What this excludes is the action sets and the app bindings for the controllers. So I made it shorter that way, so it's a bare bones project. And then we'll demo the OpenXR SDK and for the Hello XR program that they have, and then we'll go into some of the code in the OpenXR SDK code to see how that compares with the short version of it that I extracted. And then if we have time, we'll go into the demo SDK on the Quest 2 and the code in the Android Studio. Okay, so what is OpenXR? It's created by Kronos Group, first of all, and is a high-performance, royalty-free open standard to connect AR and VR devices with applications that run on them. It's a single API for developers to develop towards for VR and AR application. It handles the communications between the device and the application. And so device is something like a Oculus Quest 2, Valve Index, or Microsoft HoloLens 2, and there are tons of others. And then the device provides the application information, such as the head and the hand poses, controller states, button presses, display information, single or multiple screens, form factor. So, for example, some form factors are just the mobile, and the screen split into two, and that's single screen. And some head-mounted devices have dual screens, and one for each eye. And then the application. So this point is what the device provides. So the hardware information, and the application provides the devices, the image that goes into the device to be displayed, the audio and the haptic responses. So that's all pretty straightforward. And finally, to use OpenXR, it must be paired with the graphics API, such as Vulkan, PGL, DirectX. So this is a kind of overview of how everything works while it's running. And so here we have the VR application. And the VR application could be something that we make just with OpenXR SDK, or it could be the game engine, which it also just implements the OpenXR SDK. It could be big or small. And then it communicates to the VR runtime which is through the SDK, the OpenXR SDK. And here is where the OpenXR SDK lies, where all the red arrows join together. And so the runtime communicates with the app, and it could be also a browser, right? Because an application, a browser is just an application, and inside of that has the WebXR standard, which makes use of the OpenXR standard. And then behind that, it communicates with the graphics API, and underneath it communicates with the operating system. And the application also directly communicates with the graphics API. And then on this end, we don't have to worry about that too much as developers, unless you are a hardware maker of VR, and they have this other standard that's part. I mean, it's other part of the standard that is to do with if you want to program the other side of the runtime. And so, what is the runtime? I just want to let you guys know really quickly. In my case, this is the runtime. This Oculus app. This Oculus app that sets up the Oculus Quest 2 and the device. It's got the control. So in here, I have to have this app open. So this physically is what the runtime is what it's this thing representing, and then the app will run through that to communicate with the device. Okay. So this is a video of the app to demonstrate. It's a very short video, and so this is all you will see when I do the demo also. And oh, actually, I just noticed. Okay, you see those two cubes? Those represent the controller. These two, the hand controllers. But in my app, I actually took that out because it shortened the code, and it's pretty big. It's a pretty big part of the code. So I wanted to make it bare bones and as short as possible. So I took it out, so you can see more in here than what is. Yeah, you see a move. That's my hand controller, and I also made this customization to have the left eye and the right eye be shown at the same time, be rendered on to the monitor as well as the headset, because I wanted to be able to show something there. So, all right. So the OpenXR architecture. This is a different, a shorter view, or a different view of the previous flowchart or image that I shown, and it shows the communication flow between the app, the VR app, and the device. So this is the app, this is the device, and everything that goes in between is all the communications that happens, and then the OpenXR API is here. So these three things. So on this side, we have the API that the developers use to make their app. And then on the other side, this is what I was talking about with if you are a VR device vendor, that this is what you would care about. But for us, we don't care about that too much unless you are one of those guys. And then inside, in the middle, is the runtime, and this is created by the vendors. So in my example, that was created by Facebook for their runtime, and Steam has theirs too. And you can have multiple runtimes on your system. And then at the very end of this is the hardware device. Okay, so the OpenXR loader is a component that keeps track of it loads the right runtime for your device, and it could choose many different runtimes, and it's loaded with the app. So when you compile the app, you can have an option to include a loader or not. And not every app needs a loader, but you could put it in if you wanted to, and it will give you more options for the app for which runtime you want to run on. And then, so the loader is going to communicate through with the runtime through the OpenXR API, and then it goes through a registry pointing to the runtime, and so that's how it finds the runtime. So, and then to the XR device, and so there's no magic there. It just looks it up at a specific location in the registry, and then finds it. And then other apps can have a loader too, and then they can point to other runtimes and other XR devices. Okay. So OpenXR includes an extensions framework, and that allows over time for OpenXR to be improved with input from vendors, and also Kronos Group themselves will make extensions to improve. So it comes by default with the core standard, that just all the fundamental specifications for the basic use cases. And I got one thing to say about this is mostly this is for VR. The XR stuff right now, as of current, is mostly extensions. So the core standard is just the VR, and you'll be, if you're using any AR stuff, you'll have to use a lot of extensions. And these are extensions that Kronos Group provide, and the XT standards extensions are what the vendors get together to decide among themselves to implement without the intervention of Kronos Group. And then the vendor-specific extensions are for any one particular vendor if they wish to implement their own extensions. And then these are some examples of extensions. So platform-specific support, for example, Android swap chains, threads, graphics APIs. You got the normal Vulkan, OpenGL, DirectX, and layers. Support and other stuff. So these are just examples. And so here we touched upon layers. So aside from extensions, layers are a way to extend your app, your OpenXR app. And you can write an extension, and it's actually loaded by the loader. And API layers are actually interceptions between your app and all the way to the device. So we go through the runtime, and then you go into the device. So API layers can get in between that and do some work for you as kind of a prepackaged thing. For example, if you have any kind of logging that needs to be done, API layers can provide that. Or any kind of performance metric that needs to be measured, layers can provide that. And so this is what this diagram shows. So XR do something, layer 1, layer N, it intercepts this do something, and then before it gets to the runtime. And so this is the same overview, just more higher level. All right, so this is the structure of a OpenXR app, and to get started, you need to create an instance, and you need to choose the extensions, the layers, the graphics APIs, find out how to run, get the head-mounted devices characteristics, the form factor, as I was saying earlier, either mono or stereo, set up interactions, input handles. You need to bind the physical inputs to actions, and here we have actions and action sets, and we'll get into that a little later. And then prepare your immersive experience. So this is to create the session, and every XR app, while it's working, needs to have a session, and the session represents the runtime, and then create the swap chain to drive the display. Then you got your game loop, which handles the input and displays what is it in the swap chain to the device, and it polls for other events that OpenXR may have. For example, session state switches. So we'll get into that a little later. So this diagram is very helpful when you are programming for OpenXR. It kind of gives you a high-level overview of everything that's going on within your app. And over here on the left, you have just a general broad sense of what the app is doing. It starts and it initializes, creates the instance, it creates the session. And in session here, you can see how it zooms in with all this stuff. So most of the stuff that's going on is going on within the session, all over here. And then, once you're done, you destroy the instance and the application is complete. And the session has various flows that you go into here. Polling event being one of them that I mentioned earlier, that you can have all these state changes, like right here. And then a lot of this other stuff is kind of on the deep end, kind of beyond my knowledge, but this is kind of like the basics. So this is very helpful. OpenXR handle types. At the top level is an instance, and under that we have action set and action. And action set and actions represent input, like a button press. And so a button press would be either an on or off, so that'd be a boolean, or like a float would be a trigger. You have a range of values that you can input, and action sets are combinations of the actions. So you may have like a vehicle driving action set, gameplay action set, etc. And then here you have a session under the instance, and under that you have a space, which is there are 3 types. We'll get into that later. And then you have swap things that you render the image onto. And one thing to know about these handle types is if you destroy anything at the top level, then everything at the bottom level will also be destroyed. So if you destroy session, space, and swap chain will be destroyed. Instance, all this will be destroyed. Likewise. So the instance is the representation of the OpenXR runtime, and you can create multiple instances if supported by the runtime. And you have to specify the info, the layers, and the extensions that you want to use, or that you have to query first what the device supports, and then from that you have to see if what you want is supported by your device, and you handle accordingly. Just like many of other Chronos Group's APIs, like Vulkan, also does this type of stuff. So it's pretty normal. And XR system is a group of physical devices into logical systems. So each system is like a headset system, like the Oculus Quest 2 or the HTC Vive or HoloLens, something like that. That's a system. And after you create the instance, then you can get information about the system that uses, and it will return the type of form factor to be used. And then the session is how an application indicates it wants to render and output AR frames. And as I was mentioning earlier, most of what's going on in when you're running the app is happening in the session. And so sessions have states, and they enter into different states based on different events. And yeah, so after you get the system, then you create the session, and end session destroy, begin session when you want to start. This is the diagram of the session lifecycle, and these are the states that I was mentioning earlier. So looks very much similar to a lot of other things. You got idle, you got ready, and here is where you synchronized, visible. This is where you render the frames. And so once you're done with your app, when you want to exit, then it goes into the stopping state, then it goes on to exiting, then you destroy the session, so on. So pretty straightforward at a higher level, but more lots more in terms of details underneath all this stuff as usual. And the types of events that can be that the system will handle are these are some of the types of events when it's polling for the events at the loop, the event at the game loop, and based on these events, the session will go into different states. And there's also events that tells you that the session or the state has changed, and then after it tells you that it's changed, then you go and look. Okay, what was it changed to, and is it what I'm looking for? If so, then do something. If not, ignore it. Things like that. Okay, so modeling with interactions, with actions. So actions, as I was mentioning earlier, are inputs. So here it says a semantic bit of interaction. So as I was mentioning earlier, it's like a Boolean is a button, and a float would be like an analog trigger. For the controller, you have a pose, which is a vector 2, which is the position in space where your uh, controller is at. And you got haptic information that's coming from the controller. And so these are all bound to actions. And this is one level if in direction, so that it could be abstracted, and it could fit onto most VR headsets. So this is one way for OpenXR to be able to do its job, to be able to abstract the inputs. And then action sets. So I was mentioning earlier is a group of actions. And examples would be like a menu, action control, gameplay, driving. So at any time you could have different action sets that can be activated and be used by the player, the user of the app. That's These are the references. So now we can go into some of the demo. So if anybody's interested where I got all this information, most of the slides were taken from existing OpenXR introduction videos or articles, stuff like that. So, but this is where I got everything from if you're interested. And first of all, are there any questions? I know it's a lot. I mean, I can just keep going on and on about this. I think I'm halfway through. What's more interesting to me is when we start to look at the code. So, any questions so far? Hello, is anybody there? Are you guys there?
Yeah,
Okay.
Yeah.
No All right, no questions.
no questions.
Alrighty. Then we'll go into some of the code. So On an overview, this is the code. This is 628 lines of OpenXR app code. And the purpose of this was to kind of shorten the OpenXR SDK code into one path, which is minimal and bare bones, that which I can wrap my head around somewhat, not completely, but at least more so than the longer one. And this is a overall structure of what the code is doing. So earlier when I was talking about the structure of an app, of the OpenXR app, this code is following that structure. So starting from main, it will have the OpenXR init and OpenGL init, and after that we'll have a game loop. And inside the game loop, it will be pulling for the events that we mentioned earlier, and inside after that, it will be rendering the frame. And after that, when you exit the loop, when you exit the app, it will have a shutdown and for the XR and the GL. And so the init function, what it's doing is query and set up the extensions, the XR extensions that I was talking about earlier. And it creates the instance, the system, initializes the device, sets up the graphics API, and creates the app window, the drawing context, that which to bind the graphics API to. And after that, it creates the session, and it creates the reference space, and creates the view configuration, the form factor, stereo and mono, and it creates the swap chain. So all of that is a part of XR init. XR init, I think, is the biggest. XR init, along with render frame, is kind of the biggest part of this code. So XR init happens first, and then GL init happens next, which is kind of like the normal rounder things. You set up and bind the shaders. Can you hear me? Can everybody hear me okay?
Yeah.
Yeah, just sometimes it's very loud and other time it's quiet.
Oh, interesting. I have
It's like it's auto equalizing and getting loud soft, loud soft, loud soft.
yeah, it's got this voice EQ thing. Maybe I'll just turn that off. I don't know. Is this better?
Keep talking for a little longer.
Yeah, let's see.
I think it's a lot better already. Yeah.
Okay, cool. Then we'll just keep it off.
Great. That was an easy fix.
I just got this headphone recently, so I haven't had too much experience with it. Anyhow, the OpenGL init, it's the normal rounder things. So after binding shaders and setting them up, you got binding and setting up of vertex arrays, and into the game loop, we got the polling for the events. And inside that is also a loop, XR poll event. And in here, detect for the state changes and then processing them accordingly. And after that, oops.
Oops.
Yeah,
Sorry to interrupt.
I hear the hiss too. I hear, maybe I can tweak, maybe I can turn this on, but tweak with the parameters.
Let's not deal with that now. Just leave it as a hiss. It's just we don't need to spend too much time worrying about it. The hiss is fine.
Okay. So, after pulling the events, then it's a rendered OpenXR render frame. So in each call of this function, it loops through the view count, which represents the swap chain images. It loops through each one of those images, and it prepares them, and it calls render layer, which in turn calls OpenGL render layer, and which does the GL draw calls inside that. And once the GL draw calls are done, then it releases the swap chain images. And so that's the two important basic things that are happening: pull for events and render frame inside the game loop. And after that, it does the shutdowns, which just deletes stuff. And so that's like a one-page summary of a basic, simple, bare bones OpenXR app. And this reflects the actual code here. So this is the project, and you can see there's a lot of stuff. It's also here. This is the same main.cpp as this one. I just opened it twice, once here and once there. But what I want to show here is if you look at on the right side, how much code there is, it's almost fitting into one of these columns, but not quite. It's just a bit, just a slightly more than that. So there might have been a way that I could fit more into this, but I didn't want to start scrunching things and put them all in one line. I already kind of did that in a lot of the other parts, as much as that wouldn't obfuscate the readability of the code. For example, this stuff, the geometry, the vertices, nobody needs to really see that. Nobody's really going to read that. I put them all in one line. Anyhow, so let me just map this overview really quickly with the actual code that we're looking at. I don't think going into the nitty-gritty details of each line of code is going to help, but I can go into what each function's doing and what other functions they are calling and go into them as kind of like a overview. Okay, so starting from main, we got the OpenXR init. So let's go to main. It's at the very bottom. So here you can see the OpenXR init, and then you can see the OpenGL init, which are these two. And then after that, you see the game loop, the while loop there. And inside there, you got the XR poll events here. And then you got the render frame that is here. And then after that, you got the two shutdowns. So that is the main body of the program.
Just could you poll events asynchronously and then only render frames every once a frame is needed, and just continually poll events? Like, could you have a separate simulation cycle and render loop? Like yeah, basically the time in between polling events is much shorter than, and processing your state would be much shorter than the time between rendering frames.
Mm-hmm. Okay. I see. So I don't think that's impossible, because from what I understand here, it's just polling states. There's nothing that's binding with graphics here.
Okay, so yes, you can. You just need to make sure you're not corrupting your own data or anything. Okay.
Yeah, you just have to keep the data consistent. So this is the part in the overview here where we poll for the events. So you loop through XR poll event.
Yeah, classic
here.
Polling,
Yeah.
event polling.
Yeah. Classic stuff. And
okay, great. I'm just curious.
Yeah, no problem. I think I like questions, because I don't necessarily know what's unclear at any given time or whatever's thinking. I tend to like a discussion type of a thing more than just like a straight presentation, one way street kind of a thing. So that's cool. Okay, where was I? I was saying, yeah, so we got the main function, right? And I was saying earlier about OpenXR init and then the render frame. That's where a lot of the stuff is. So let's go into the init, XR init. Okay, so here you can see it's asking for the OpenGL extension. So we're gonna put in the ask extension into what extensions that it does provide. We're gonna ask, does it provide the OpenGL extension? And this loop here is just printing all the extensions that are available, just looping through the extensions that are available. And then if any of the available extensions matches the OpenGL extension, then we're good. We can continue to go. And then we create the instance info, which is put into the instance creation function to create the instance. And this is the instance XR instance object. So you got all these info, and you name it, all the normal stuff, app versions. And then you create the instance. If you don't get it, then return false and fail out. Otherwise, use the instance and get talking to the runtime. And I believe this is a function pointer that's pointing into the runtime, because you'll run this later. Yeah, so you run it here, and you get a requirement from it that you use later, I believe. Then after you got the instance, then you get the system info, which I was mentioning earlier about the form factor, what system this is, what it supports. And then we got the blend mode. Not sure exactly what that is, but it seems like a setting for the image views and stuff. Yeah, and here we got device init, and device init just goes through and inits OpenGL requirements with the runtime. And important thing here that it does is create the app window. And the app window, this is the Windows style of creating the app window. Got the handle instance, H whatevers and cursors and all that. And at the end, you call this to create the window, and you get the context, and then you set all these global variables with the context, so that once you have this drawing context, then you can bind the graphics to this context so that OpenXR can draw to it. And then you need this one too. I forgot what that is. Some details. So after that, after you got the system, then you create the session. Then you fill in the session details, and you ask it to create the sessions. If you get one, then we're good. If not, fail out. And now you have the reference space. And reference spaces have 3 types. I guess didn't talk about this earlier, but you got local, you got view, and you got stage. And local, let's see if I can get an enum spaced reference type. Yeah, let me see. How about this? Yeah, view, local, and stage. And stage is the world. Basically, everything that's outside of your reachable area with the device. And local is the space that is around you that is included with the head mount display system and your controllers. So the space that those things are moving, that's local. And the view is always bounded to right in front of you, your face. So no matter where you look, you always see whatever you render to this view space um, all the time. So that could be useful for different things, maybe UI and whatnot. And so then here you create the reference space. Yeah, so we got the reference space, the type, stage and local. So we got two here. So we got the stage, which is the world, and we got the local space, which is the device itself. And after that, we set up the swap chain. And so the view count is what I was referring earlier. For each one of the swap chain images, you loop through them, and then you create the swap chain. And here you're just setting up some basic info about the swap chain, width, height, sample count, things like that, and then you create it, and then you save it to this swap chain. I believe it's a vector. Yeah, it's a vector. So this swap chain structure is just this. It's got the handle, it's got the width, height, it's got the images. Yeah, and so that whole thing is the init, which is the most important part of programming OpenXR. I guess a lot of other Chronos APIs too. It's just it could be huge. You could take and not to mention I've left out, I mentioned earlier, the action set and the action binding for this. If you look at the OpenXR code for that, it's quite big. It could get quite large with the yeah, here. So you got these XR paths that indicate some kind of a hierarchy of the controls that you're looking for. And so I've omitted that entire part so that it fit, because I just wanted to get a bare minimum working. But so if you include all that stuff, it make the XR init even bigger. Yeah.
Oh, sorry, I'm getting ahead of myself. Never mind.
Yeah, no worries. Yeah, so we got the init, then we had GL init, which is just your normal run-of-the-mill GL stuff. Got the shaders, vertex shader, fragment shader, compile them, create the program, link them, delete them, and you got the buffers, setting up the vertex buffers here. So this comes from the plane is yeah, so it comes from that long definition that I was saying earlier about let's see. That's probably this one, C plane. Yeah. Yeah, here. So we got multiple different geometries. So if you look at the video, we have in the scene, let me just show it again. We have a sphere, a cube, and a plane. And I was mentioning earlier that I don't have the controllers in the actual code, but in this one I do. But I ripped it out, so that's what the geometries are reflecting. Just those three things. Just the oops. Yeah, the plane, the cube, and the sphere. And the sphere was just generated from some other program that I found online. I forgot which one it was. Yep. So it just it binds the buffers for that, and it doesn't draw them yet. It just sets it up. And then okay, I'm just backtracking. So after the init, we already looked at inside the loop, the poll events, the normal stuff. Then we have the render frame, which is the other big one. And here we have the session. So you kind of put it into this state where it waits for the frame, and you want it to also begin the frame. And you do some magic stuff that I'm not sure about. This composition layer base header seems to be needed, and stay active. You make sure the session is active, and you call OpenXR render layer, and in there you deal with the swap chain. So you loop through each one of the swap chains, and you acquire the swap chain, and you, after you get the swap chain image, then you put it into this function, GL render layer, and that's where you use that swap chain, and you use OpenGL to draw what you want to draw. And here's the actual draw calls for the for OpenGL. You know, you clear the background, and then use the shader program, and then all the normal stuff. Do your transformations, and then bind to the buffer and draw the elements for each one. So each one of these chunks is one of the things: the plane, the cube, and the sphere.
So
And-
input to this method is, I guess it's telling you which eye you're rendering.
Yeah, exactly. So for a swap chain, you have image for each eye, and it just loops through each one of those swap chain images. And I believe also I think it needs to be double buffered for each eye as well. That's why it looks like it's a double loop. It's a loop within a loop. So you got this outer loop here for each eye for OpenXR. But then once you get in to the rendering layer, you also I think, didn't we have another loop here? Or maybe I'm
So I guess
confused.
is view count, is that 2, like 1 for each eye?
Yeah. View count, I believe, is 1 for each eye for the swap chain. So so this would be like 2, or yeah, it'd be 2.
Okay. Yeah, that makes sense. And then right, the double buffering's here in the acquire swap chain image here.
Yeah. Yeah, exactly. So it's drawing all this stuff. Yeah, render, or maybe it's here. I think it's out here. Render frame? No, it's not.
I saw at the
Yeah.
bottom there was a swap buffer. At the bottom of your OpenGL render
Oh,
layer.
open.
Yeah, in the bottom of OpenGL render layer, looked like there's a swap buffer. Yes, line
yeah.
589.
Yeah, okay, so there it is, right? And so this is a bit of code that I added to get the display to show up like this, half and half, 1 for each eye. This doesn't come with the SDK. So I had to modify it to, essentially that's like the only extra meaningful work that I did to make it different than what is provided in the SDK. And I applied this to the SDK.
Is that image that you're looking at right now, is that just like the mirror? So you have the frame buffer, the render of the frame buffer, and let's see here. Yeah, so the render, the original frame buffer is to 1 second.
Mhm.
Yeah, the original render of the frame buffer is to the swap chain for the eyes, and then are you doing another render for the mirror then?
Yeah, so it looks like for yeah, it doesn't look like actually I am doing any left or right eye detection. It looks like it's just a mirror. Yeah. So yeah, it's been quite a while since I did this, so don't remember exactly. But from looking at this, it looks like it's just a mirror. So it's just a duplication of the image. But the idea was to, I mean, if you guys, know how to do like more in depth, I would like to have this one left image being the left eye and right image being the right eye. So that's the ideal that I'm going for. Yeah, and so render layer, I think that almost completes everything. Yeah, render layer and render frame, shutdown. Shutdown is just a bunch of deletes. GL shutdown, delete all the buffers and all that stuff. And let's see, the other shutdown is for the XR, and that also destroys all the XR artifacts. So it destroys the swap chain, loops through them, destroys the space, destroys the session instance, the app window, and that's just some of it. The program. And if you let me show this first as a demo, then we'll go into the OpenXR SDK itself, which is much larger. So let me try to see if I can get this working. No presentation is complete without a demo. Have to, and it must fail. It must not work and say, hey, it works all the time, but somehow it's not working because it's a demo. All right, let's see. Okay, so here's the executable. I'm gonna put on my headset over my headphones, see if that works. Oh, oops. Just broke my headset. One second. Yeah. All right, let's see if this works. I have my headset on. And then to throw another wrench in it, we're streaming with the video, so who knows?
I've streamed from my headset before, my VR headset, and I can confirm it's just as much of a pain as it looks like. It's doing right now. So.
All right, let's see if it works. All right, it's working. Well, I'm moving my head.
Sweet.
Not so it's impressive. It's quite underwhelming, but hey, at least it works.
Yeah.
It looks like you do have perspective differences between the views.
Yeah, I like that.
Do
I like how I thought.
Oh yeah.
I would have thought having a like view both eyes mode would have been like a standard thing in the SDK, but apparently not.
Yeah,
I guess since you render with that index, that's a way to distinguish which eye it is.
oh, the index, right here. Let's go back into it. All right, here. Index 0, index 1. Okay, what is index? Oh yeah, it's being passed in.
Is
And
it being used anywhere else?
comes from I. I is from the loop. And it's part of views.
Ah.
So views comes from, oh, I think we initialized that in the beginning. Views is being passed in. And where does it come from? Views. Composite layer projection views. And that's an XR thing. Okay. So, yeah, it's an XR thing, so it gets, I think the index is the left and the right. Yeah. Okay, cool. Hey, I'm glad I did it right somewhat, I think. I mean, I don't know. All right, so I think this one is frozen on the screen, but it's still moving on my headset. I'm gonna shut it down. While I have this, what I can do is show you the SDK, the OpenXR SDK program. And that one is called Hello XR. And it, yeah, I just want to do that so I don't have to put on my headset again. So this one is from the SDK, and you have to run it on the command line because it takes as a it takes as a parameter. So if you just run like Hello XR, for example, it wants the graphics API. So if you do OpenGL, then we'll have what I had before, OpenGL. Oh, G. All right. So here you can see my hands. It's moving around. You can see my head, and that blue square in there, that's the view space. See how it's always in front of my face? Oh, and I'm inside a cube, by the way. If I look, I'm tilted on the side. This is like where my head is. I'm looking on the side, but if I just sit up straight, then I go right inside it. So that's where my original head position is, where I started. So I can look at that. And then my hands, and there's two cubes down there on the lower right corner, and then two over there on the left corner. So this is the Hello XR program that comes with default. Yeah, okay, so let me exit this one.
And in that app that you just set up,
yeah,
that was, so were those cubes in stage space, I guess? Because that's kind of like the world space.
Yeah. You mean the cubes down at the bottom there?
Yeah.
Right? Yeah.
Yeah, not the ones attached to your hands, but well, I guess those. Well, yeah. Regardless, what you use local space for?
Local is for your device. So I believe it's for the hands and for your head. So you saw here. Let me do it again. You saw like I had three different cubes. One for my head, one for my or two for my controllers. I believe those are in the local space. And then
that makes sense. Thank you.
yeah. And then you saw another one in the view space. That's just a square that's blue that I'm looking at all the time, no matter where I turn my head. I mean, I can show it again here while I have this on. Yeah. So local, that right there is my head, and then you got the view. See that square always there, and that's down there is the stage. Yep. Alrighty. And I guess last thing before the extra thing that we can go into is the code that is in the OpenXR. But while I have my headset on, I don't know if I should show the well, so since I started doing this presentation, I got a bit more into it because I've always wanted to deploy the OpenXR SDK on the mobile side instead of just the PCVR side, which is what I did before, which is what you saw, what I presented. And then while doing this whole thing, I got the mobile SDK to work, and it's quite different from what they provide in the actual SDK. So, and but the problem is setting that up is gonna require like streaming from Oculus, which I've done before. I don't know if it's gonna work. I don't know. What are you guys interested in? Do you want to see that, or do you want to just see the code, or what do you guys want? Any suggestions? Nothing.
I'm interested in I guess what's required in getting started with the Quest there. So yeah, carry on.
All right, so we'll just go into the code then, right? Yeah, and I can show you the code for the mobile side too without doing the demo, because they have videos of this online too. So anyhow, let me take the headset off. I'll be right back. Hold 1 sec. All right, headset off. Um, so much easier to share screen. uh, okay, let's go into the OpenXR. Can you guys hear me? Okay.
Yeah, sounds good.
Okay. Cool. All right. So the OpenXR SDK is much bigger. It supports different platforms and it supports different graphics APIs. For me, my project, I just took one path, the Windows, combined with OpenGL path, and just shrunk it down to as much as I could. But it starts with the main app, the OpenXR. If you look at the structure of the main app, it's quite similar to what I had. It's just much bigger, but the structure is the same. So here you go in, and it's doing some validation stuff. It's creating the instance, initializing the system. It's separated like whereas I had one function call for all this stuff, it separates them into different functions. So this is all XR stuff, creating the instance, and render frame here is like my equivalent of the OpenGL render frame or XR render frame. And from there, we have the OpenXR program running, and this is where all those, the program itself is, yeah, create OpenXR program. It returns an OpenXR program, which is like this type, I think. Yeah. So it inherits from this interface. And all those init functions are in here. So for example, We got pre-instance, init system. So much more in depth. It's got logs and other stuff. And one thing that I mentioned earlier that I stripped out of my example is the action sets and the actions, the input states. And so that's initialize actions. And that's somewhere here. Initialize actions. Let me see where it is. Maybe it's in a function call here. Ah, okay. So it's inside of initialize session. In that they also initialize the actions. And there's a video on YouTube that explains this in very great detail. And it's actually the guy that wrote this stuff. So if you look at the log, this guy named Ryan Pavlik, he's the guy that's presenting this video. He's like explaining to you what this all means. And I have that in my reference, but I learned a lot from this video of my presentation, what I presented. Some of the slides are from this video, which he provides the slides on a different link. This is the slides, the same in the video. So if you are interested in the details, you can of the OpenXR SDK, you can check out that video. And this guy Ryan Pavlik, yeah, he is the person that is actually doing this presentation. Yeah, Ryan Pavlik. Anyhow, let's go back. Yeah, because he uses in the video the same exact words and setup that is written in the code. So it's very convenient. That's almost one-to-one. It's got grab object, hand poses, all this stuff, gameplay. Here are the XR paths that represent each of the inputs. So they go through setting this up. It's quite big. You see, it just goes on and on and on. And it sets up the interaction profiles, which is kind of like some standard presets for each device, each system. So this here we have the Vive controller. You also may have like Microsoft here, you know, Quest 2, maybe somewhere. Oculus touch controller here. And then the simple controller is kind of like default that if you don't know which one it is, if your device is like a one-off or something, then it'll probably use this one. Won't find any of the interaction profiles of the other vendors. Yeah, so this is a big chunk. Then you have the graphics API plugins. So they call it a plugin. Basically, it's just implementing this interface, and you can have OpenGL here, and you can have others like Vulkan and DirectX 1 or 11 and 12 there. And it's got some of the rendering functions that like shader, init, compile shader, so on and so forth. Yeah. And to set this up, just follow the directions. What I did is just follow directions of SDK source. So there are two. There's two SDKs, the SDK and the SDK source. And I found that, I mean, I used both of them, but I found that the source was the only one that worked. And the SDK itself at the time, it was about a year ago, it didn't work for me. So I kind of dropped it and went with source. And source worked, but it's been quite a while. So if you look at my commit log, it's like almost a year ago, I believe. Who was I looking at? OpenXR. Yeah. So this is the OpenXR SDK source. Show log. So the last one I pulled, Ryan Pavlik, last year, almost about this time. So it's quite old. Hopefully the regular SDK is easier to use now. Haven't tried it, but try both. See if you are to try. Just see. This is the recommended one that they ask. They say you don't have to go to the source if you could get this one working. So that's supposed to have the Hello HR example in there too. And I just followed the building like directions. They have like where is it? Building MD. Yeah, just read and do, CMake, blah, the normal stuff. And I guess one last thing is let me close this. What I was saying about the mobile SDK, which is where is that? This one. Yeah. Yeah, the one that I was using is from Android Studio. Let's see, do I have? I don't think I have Android Studio set up. This is the portable version. I use portable because Unreal needs a specific version of Android Studio in order to deploy to Quest. So it's installed, but it's like an older version that Unreal supports. So this is in Android Studio, the project. It's doing stuff. Yeah, and to get this working, it's pretty simple. I mean, it's always simple once it's working, right? But it did take a little bit. Didn't take too long, but it took a little bit. Okay, so all I did was open up Android Studio. I unzipped the package and I dragged this file in there. And once I did that, it got a whole bunch of stuff, churning and reading through and working. And if you want to do the same thing, there's a video that goes through, and that's what I follow. This video that it's in the reference somewhere. It's one of these videos that yeah, I don't know which one, but it's one of these that goes through how to deploy the SDK. First of all, open it up using Android Studio, but it doesn't go into the details of like how to install Android Studio and all that stuff. But if you use if you don't have experience with this, one of the important things is in Tools, SDK Manager. Here, you want to get the right version of the Android SDK tools and NDK. And you won't be able to see all this stuff unless you click Show Package Details here. So if you don't have that, it's just kind of plain. But if you have,
I apologize for spacing out a little bit. Is Android required for building for the headset you have?
Quest 2?
Yeah, the Quest 2.
Yeah, so if you want to deploy the mobile application onto a Quest 2, you have to have Android Studio. But if what I was showing to you guys was PC VR. So I have a cable that connects the connects the Quest 2 onto the Windows, and that app was compiled in Windows and ran in Windows.
So it's like a client server versus running it locally,
Yeah.
kind of
Yeah.
thing.
Exactly.
Okay,
Exactly.
that sounds, yeah, that explains why Android Studio is needed, because the Quest is an Android platform in a nutshell.
Right. Exactly.
Okay.
Okay, so the Quest will show up as a device. Oh yeah, I see it in the top
Yeah.
right there.
Right
Perfect.
there. Yes. Yeah. So this I always wanted to do, like, but I just never got around to it since last year, since I did the other one. But because of this talk, I got around to this. So
Nice.
that was a good thing. Yeah.
So if you ever deploy an application to Quest 2, you definitely need to have this set up. If you just want to do some hacky development for your own fun, then you could just run it off the PC and be fine.
Yeah. Exactly. Exactly.
Lovely.
And so PC is probably like the first place to go to, and then once you get a little more in depth, then you get onto the device. Because also PC is just more powerful. It's easier to render fun stuff and complicated stuff with.
Yeah.
So yeah, I think that about covers it all.
I
Guys,
guess would you say that you can iterate faster on the PC
oh
development?
yeah,
Yeah.
yeah, for sure. Because for this you have to deploy every time. On PC,
Right.
you just compile and run, and that's it. And that's how I made this thing. It's just on the PC, and I think um, what I want to do in the future as a workflow is just to do this PC stuff first, do it fast, and once I have something I'm satisfied with, then I'll do the whole Android Studio stuff later. So yeah, that's just what I'm thinking off the top. Yeah. Any other questions, concerns, jokes, funnies? I don't know. Answers, maybe somebody can answer some questions.
Well, you were mentioning at the very beginning, talking about the design of the API with the layers. I just wanted to confirm that yes, the OpenXR API was heavily influenced by Vulkan. A lot of the same people working on Vulkan then went on to define the other API. So the style of the API, but also some of the mechanical aspects like the loader and layers are taken in some cases wholesale.
Yeah,
So I just want to confirm that suspicion.
and this here is yeah, for sure. I mean, it's Kronos Group, right? So
Right.
it's the same group of guys that are.
It's my pedant side of me says it's not all the same guys, but a lot of similar. The two groups have very shared overlap.
Yeah.
So, but also you get some of the same people doing the like legwork, whereas there are some companies who define what they want, and then the same people are working on the tools or the loader or layers or whatever other the sample documents and whatnot,
Yeah.
sample implementations. I mean,
Yeah, for sure.
um,
And I found this just before the presentation. This example of a layer that
I've
this.
heard about some of the silly things that have gone on in its development,
Yeah.
because I know the guy working on this, and it's interesting to say the least.
Yeah, it's a good example, I think, because maybe somebody wants to develop layers and they don't know how, and they could just look at this. And that's how you do it, right?
I mean, it's I don't. Is this a? I believe this is a. Oh yeah, this is an example layer. I'm thinking of something else. So yeah, but yeah, the overlay stuff is interesting since in a graphics application, a traditional desktop graphics application, you have the screen and it's this flat thing. And if you want to put an overlay on it, you can just put your overlay in the corners and it's happy because it's the corners. It's free real estate, whatever. But in a VR application, it's a whole 3D space, and so an overlay isn't just like put in front of your eyes because that would make you
Oh,
nauseated. It's
Yeah.
also like a three-dimensional object that needs to be embedded in the scene.
Right.
When you're
Right.
using VR, you have the runtime, and that's like Steam VR's runtime. You press a button and it brings up like a menu sort of thing. And same with Oculus, they have their own menu, and it's like that's the kind of layering that needs to happen. It's a lot more involved than just a little text box, because it
Yeah.
needs to be in 3D space, and defining where that is and how all those other things are quite interesting.
Yeah. Yeah. For sure. Yeah. Definitely. If you don't have the depth, then people will not be happy. Just yeah. Awesome. Alrighty. If there are
Thank
no,
you for
yeah,
presenting.
no problem. It's long overdue. I
Thank you very much.
should share something. Yeah, no problem. Yeah, let me stop sharing my screen. I will, yeah, now we can just hang out, I guess.
I tried doing XR stuff, and I got to the point of creating an XR instance, and then I got distracted. Also, COVID happened at the same time, and I just lost motivation. So that's fun.
Yeah, yeah, it
The
happens a lot.
lockdown happened more than the COVID happened, but whatever. I still haven't gotten around to actually making a proper XR application.
Yeah, yeah. It's it took me like 2 weeks to get all that stuff going.
It looks
But
it looks fun though.
definitely, definitely. Just wish it was easier to um. It's very cumbersome, right? Because you have to put on your headset and take it
Oh
off,
yeah.
code, and it's almost like it's like worse than mobile. Because mobile, you have to like look at the device and test, and then go back and redeploy and blah blah blah.
I almost wonder if there's two solutions to the problem, the annoyance in development, not the difficulty. The one is a desktop emulator where you just are doing everything on your desktop and pretending to be in VR, or
Right.
so you don't actually have to get up and walk around. You can just sit there and mouse and keyboard and whatnot. But the other thing is maybe people should do development in VR, full time. And I'm just like, maybe we shouldn't do that.
Big floating text.
Yeah. Yeah. Right now, it's just asking for iString bundles. I you know, but
Maybe
once
someday for AR device, not VR, but for I guess it's kind of mixed reality device like HoloLens. People can try because at least you can see keyboard.
Oh, okay. I've used the
oh
HoloLens.
yeah.
Um, the application I was working with was Unity, and due to the stupid networking setup of university, I could not get deployment from Unity set up. So at any time I wanted to actually run it on the HoloLens, I first would have to build a Visual Studio project, which took like a minute, like the Unity build, not the Unity run stuff. And then
Oh
after building it, you would deploy to it, which took another minute of compiling and uploading.
Yeah,
If it
it's the biggest problem.
if it wasn't for that, I would be able to code to click play and have it be in the headset wirelessly, which would have been amazing. And apparently the lab TA for the lab that let us use the HoloLens got that working at home once, but because this was a lab property, I couldn't do that. They didn't want a $5,000 headset disappearing.
yeah. That's a bummer.
Well, the whole class was odd, and I won't get into it because it kind of distracts from what we're talking about here.
It's all good. Yeah, it's fun stuff. I mean, it's fun to be ahead in the forefront of like whatever's going on with XR. It's just we're seeing it unfold, but it could be just a flop, Like a lot of people don't care about it. They're like, it's a gimmick. But who knows?
I think it's less of a gimmick than the last two times, but it isn't a complete runaway success like a certain company wants us.
Right, exactly. And they're like betting the whole company on it. And
Yeah.
it's really funny.
I mean, I would argue that the Quest 2 is pretty darn cool hardware. I wouldn't bet the company on it.
Yeah. Yeah, we'll see. They'll have to come up with something that keeps this thing on people's heads for a long time.
That's OpenXR, why it's good. It's because you don't need to that kind of develop that of infrastructure, and then it's just become useless once the company get bankrupt.
Oh yeah, yeah, exactly. Yeah, yeah. The standard is good, so that you can have these apps that keep working on older hardware that's compliant.
What I kind of wish we had talked a bit more about is the input handling stuff, but from what you described, it was pretty darn complicated, and but in a good sense because it allows you to do a lot with it. It's just for a I want something drawing on the screen type demo, it is a bit much.
Yeah, and it's not too bad. It's just like a lot of stuff. It's just like quantity, in terms of
Okay.
complexity. Like, cause you got to do something for every button, and you got to do it once for the left hand, once for the right hand, and you just a lot of stuff.
Yeah. I think it's pretty interesting that they had a standard input mechanism as well as rendering. Because I come from render first. Who cares what the inputs are? It's just button presses, but it turns out that's actually a very big part of the ergonomics of API, where you have a wide variety of controllers and layouts and configurations.
Yeah, yeah, wide variety, and it's good because I watched a video of Unreal talking about their implementation of OpenXR. So if you make an app, a VR app in Unreal, it's just one binding. It's the OpenXR binding for your controller. So you do that once, and you package your project, and whatever controller it finds through the runtime, they just use that.
Hmm.
So that, as opposed to before, you would have to. I mean, I remember doing this before OpenXR, which is like a year ago. Like you have to do for the same button bindings for each device that you're gonna support. So we had like HTC Vive, we had Oculus Rift, we had Quest, and like some generic VR device, like a catch-all, and like 90% of the time it didn't work at all.
You had to manually test it and verify that it worked as you thought it should, but it didn't initially.
Yeah, yeah,
That's,
exactly.
That's a very silly.
So now the world is a much more peaceful place with bindings. Hey, I have a question with the chat. Does that go into general, like what we're looking at while we're chatting, in the stream? That is that the general?
Oh,
It's kept
no,
in the general voice chat.
it's for this voice chat channel. So if you want to go back and look at chat, it's in here.
But it only lasts while this lasts, right? It will go away after we
No.
all end.
No, it will be kept here, so you can still look at last week's chat.
It's retained, yeah.
Oh, but I have to be in the voice channel? Is that right?
No, you don't need to join to look at those chats.
Oh, there's a button that says open chat. Okay,
Yeah.
I see. Cool.
Do you know how you mute yourself in Discord? Is there like a keyboard shortcut for that? Not the general button. I know how to do that.
You have to set that up
Really?
manually. I think it's unbound by default.
There's a push to talk. I use that.
I'm just on my work computer.
Space. I just pushed the space key because that's the first thing pop into my mind and it works. So I guess space is the default binding.
Yeah, in the browser it doesn't.
Yeah, I have mine on right alt because I never used that key.
I'm just at my work computer because I didn't get home in time, which is why I was late. So I'm like trying to figure out how I can mute myself since my microphone is not very good at being quiet when I'm like typing and writing stuff.
Yeah.
I've got the same problem. Gotta lav my clips to
Control
the
Shift
cable
M.
from my headphones.
There we go. I actually might leave a bit early and try to join in like 20 minutes because I need to get home before the sun sets. I don't need to, but I would like to. So.
I'm gonna go ahead and cut out the recording.